Okay, just looking at question 11b from exercise 4D, I think, absolute value functions. Find the x and y intercepts and sketch the following absolute value function using symmetry. So remember, to find the y-intercept, we put or sub x is 0, so we get y equals the absolute value of 9 minus 3 times 0 is 9 minus 0. So it's the absolute value of 9, which is 9. So far, we know that our absolute value function passes through 9. So when x is 0, y is 9. So now for our x-intercept, we're going to put y equals 0. So we are solving the following. Solving the absolute value of 9 minus 3x equals 0. So that means that 9 minus 3x, just using the first case where that's positive, so 9 minus 3x has to equal 0. That's using cases if 9 minus 3x is positive, okay? So we get, if solving that, we get 9 equals 3x, or x is 3. Now, if we also did so that's case 1. Okay, 9 minus 3x equals 0. And case 2 would be the negative of 9 minus 3x equals 0. So negative 9 plus 3x is 0. We actually just get the same answer, that 3x is 9 and x is 3. So I'm going to put in my x-intercept of 3. So obviously, we remember it's a V shape, so it looks like this. And what we could do if we wanted, we can sketch the rest of it by symmetry. So if we think that the curve goes like this, okay, it goes like that, then let's just have a look. From this point 3 to the point 9, so you go across left, we go 3 to the left, 9 up. So if we want to do the same thing up here and write down what this point is, we would go 3 to the right and 9 up. So this point up here would be 6, 9. And if you want to check that it is correct, you can substitute x is 6 into this equation. So just checking, when x is 6, y equals the absolute value of 9 minus 3 times 6, so it's the absolute value of 9 minus 18, which is negative 9, and the absolute value of negative 9 is 9. Okay, so the curve definitely does go like that. So what you can do if your absolute value function looks a little bit trickier than just x plus something, you can just find the y-intercept and the x-intercept. You really don't need to do, you can see for case 1 and 2 that you got the same answer. This will be the case if it's just absolute value of 9 minus 3x, something like that, without a plus 1, or that you'll get the same answer for those. Now, let's look at another example, question 11D. Y equals the negative absolute value of 3x plus 7. We're just going to do this by x and y intercepts. So for the y-intercept, we're going to put x is 0. So we've got y equals negative absolute value of 3 times 0 plus 7. So it's the negative absolute value of 7, which is negative. The negative stays there, so it's negative 7. So the y-intercept here is negative 7, just doing a quick sketch over here. And now for the x-intercept, we put y equals 0. And we go 0 equals negative absolute value of 3x plus 7. What I'd like to do is just take the whole equation to the other side. So I get that 3x plus 7 equals 0, all right? So remembering, we've got the first case where this is positive, so 3x plus 7 is 0, 3x is negative 7, x is negative 7 on 3. And if you did case 2, you would get the same anyway. So you'd get negative bracket 3x plus 7 is 0. So negative 3x minus 7 is 0. You've got 3x is negative 7. And so x is negative 7 on 3. So same thing here for this case as well. So that's actually negative 2 1/3 approximately. So I'm just going to put it roughly here. I'm not going to plot all the points. Now, let's look at the equation or the function. It's a negative absolute value function, so it'll look like that. And so from what we've got, that the y-intercept is -7 and the x-intercept is 2 1/3, -2 1/3, we can sketch this here. Okay. Now, it's going to be a little bit harder to find the corresponding value here, but you may just want to just put any other x value here. You might try, like say x is, you could just do it by substitution. You could substitute x is -3 or x is here, if you wanted another point on the curve, but you don't really need one, you could substitute x is -3 or -4. But we're not going to get the same y value of -7 unless we do -4 1/6, which we don't need to do. Okay, so that's fine for that. If you needed to write the equation of the branches of each function, just going back up to the first one. So if you want to write the equation of each of these, you just have y equals 9 minus 3x is one of them for case 1. Now that's got the negative gradient, so that would be this one because this is -3x plus 9. That's that equation. So that is that branch. And the other one will be y equals, and I'll put a negative in front here, -9 minus 3x. So it's -9 plus 3x. That's y equals 3x minus 9. This has the positive gradient. So this is y equals 3x minus 9, the equation of that branch. Okay, and this one is y equals -3x plus 9. It's got the negative gradient and the y-intercept of 9. This would have a y-intercept of -9 if the line continued. Okay, now for this one, just looking at the two equations from what we've got, so we have this y equals negative absolute value of 3x plus 7. So we keep the negative there. This can either be positive, so the 3x plus 7 can be positive if 3x plus 7 is greater than 0. So just expanding that, our first equation is -3x minus 7. Now that's got a negative gradient and a y-intercept of -7. It must be this line here, this part of the function, sorry. Y equals -3x minus 7. And the other equation of this line, we've got negative. Now this could also be negative, what's in here. So this is case 1, this one here. And case 2 would be if what's in the absolute value sign is negative. So you put the negative here, but then it's negative again of 3x plus 7. So it'll be negative or take away negative is a positive. So the equation of the line is 3x plus 7. Now that has a positive gradient and its y-intercept would be 7 if the line continued. So if this line continued, its y-intercept would be 7. So the equation of this line is y equals 3x plus 7. Okay? The question from exercise 4D, it's in the challenge section. So it says, for what values of x is this function here, y equals absolute value of x over x undefined? Now we know that we cannot we cannot divide by 0. So the value of x for which that is undefined is x is 0. Then we can draw up a table of values of x from -3 to 3 to sketch the graph. So when we get, because we know that 0 is an asymptote, x is 0 is an asymptote, we might just put -1/2 in there. 0 we know is undefined. We can do 1/2, 1, 2, and 3. So we're substituting into the function y equals the absolute value of x over x. And over here we'll be sketching the function. So let's start when x is -3. Absolute value of -3 is 3. Then you're dividing by -3, so 3 over -3. I'll just do an example here. If x is -3, we get absolute value of -3 on -3. Well, that's 3 over -3, which is -1. It appears that you'll get the same answer there for -2. You'll get 2 over -2, and same answer for here for -1, and 1/2 divided by -1/2, that'll also be -1. So these all appear to be -1. And on the other side, let's look at x is 1, say. or x is 3, doesn't matter. So when x is 3, you get absolute value of 3 on 3. Well, that's 3 on 3, which is 1. And you'll get 2 on 2, which is 1. 1 on 1, which is 1. And a half on 1 on a half, which is 1. So it appears that you cannot have x is 0. But for values of x greater than 0, the value of your function is 1. So if I make this 1, I have an open circle. And the equation, we'll write the equation in a minute. And for negative values of x, like these, you get your y value is -1. So that's at -1 and this is 1. So you can now write down the two equations of the branches of this. So you can see what they are. The equation of this line is y is 1. And the equation of this line is y equals -1. But I'm just going to show you how you can do that algebraically down here. So case 1. For y equals absolute value of x on x. Now case 1 is when x is positive. So for x greater than 0, we can say our function is y equals x over x, x divided by x, which is 1. So that's why we're getting that y equals 1 for x greater than 0. And for case 2, which is for x less than 0, we've got y equals absolute value of x on x. Now, when x is negative, the definition of absolute value of x is the negative of x, the negative of whatever value you've got there over x. So it's negative x on x, which is -1, which is why our equation is y equals -1 for values of x less than 0. And we can see that branch of the graph and this one here. And don't forget to label your axes as x and y. Okay. Now in question 15, I might just look at 15a. So asking us to sketch y equals the absolute value of x plus x. You can use a table of values. They've suggested that you do, but we can use cases. So case 1, where x is greater than 0, where x is positive. The equation would be, now if x is positive, you just write it as y equals, this would be an ordinary x, plus that x would just be ordinary. So you get y equals 2x. And case 2, where x is negative, we would get, so we've got, what would happen with our absolute value of x? Well, the definition is, if x is negative, you've got negative x plus x. Now, negative x plus x is 0. So these are the equations of your two branches. So our first is, so when x is positive, we've got y equals 2x. So I'm just going to plot some points. So I'm going to plot when x is 0, y is 0. Actually, this is for y. We better also look at when x equals 0. So I might just do that here. When x equals 0, y is just 0 plus 0, which is 0, so I can include that point. There are no values of x that are not allowed, like in this question here. The values, for what values of x, the function here was undefined when x is 0, which is why we've got the open circles at when x is 0. But down here, we are allowed any values of x, so there is a closed circle. When x is 0, y is 0, so that's not a problem there. We also now, if we do a little table of values, when x is 1, y is 2 times 1 is 2. And when x is 2, 2 times 2 is 4. So we have this steep, bit of a steep branch there, and that the equation of that is y equals 2x. And when x is less than 0, the equation of our line or of our graph is y equals 0. Now y equals 0 is the x-axis, so I need to draw this nice and thick, maybe in a different color would be a good idea. So that's the rest of the graph. It's there, and then the graph goes up here as well. Okay, so, and this is y equals 0, but the equation of the function is only y equals 0 for values of x less than 0. So it's not y equals 0 along here. For values of x greater than 0, it's y equals 2x. Okay, now one final example. This is a little bit tricky. I'm just using Desmos for this. So we've sketched y equals 2x plus 1, which is the red graph. And the blue graph is y equals x plus 2. Okay, now we can clearly see that these two graphs cut or intersect at the point 1, 3, or when x is 1 and when x is negative 1. So from Desmos, we can see that the graphs of y equals absolute value of 2x plus 1 and the graph of y equals x plus 2 intersect or cut at the x values of 1 and negative 1. I'm just going to show you how we can solve this using absolute value functions and writing two separate equations. Go and do this on paper. Just want you to notice something, that the blue line cuts this branch of the function where the function has the positive gradient. So if you want to find the point of intersection here, you would solve the equation, you would solve simultaneously the equation of the blue line with the equation of this particular red line there. Okay, now if you wanted to find this point of intersection on the other side, okay, so this one here, you need to solve the equation, solve simultaneously the equation of this blue line with this section of the absolute value function, so the one with the negative gradient. Okay, so we're going to now do that on paper. So we've got this here. So to find this point of intersection A and to find the point of intersection B, point of intersection A, so this is the equation of the straight line, y equals x plus 2, it always is that, but the branch of this equation, so if I want to solve this simultaneously, what we're really doing is drawing y equals the absolute value of 2x plus 1 and drawing y equals just the straight line x plus 2 and seeing where they intersect. That's how you would solve that. And reading from the graph, we know that our solutions when you solve, reading from the graph, so from the graph we can see that x equals 1 and negative 1 are our solutions. But what we're going to do is solve this using algebra. Now the thing is, this absolute value of 2x plus 1 really represents two sections of straight lines. So I'm going to look at them both. So y equals 2x plus 1. So case 1, we know that y equals 2x plus 1 for x greater than 0. And in case 2, which is x, it's not x is greater than 0. It's when this whole thing is positive. And case 2, we've got y equals the negative of 2x plus 1. Okay, so this would be when 2x plus 1 is positive. We have this equation. And case 2, when 2x plus 1 is negative, we have this equation. Now, so this second equation here is y equals negative 2x minus 1. And the first equation is y equals 2x plus 1. So, looking at the dotted line, which represents my absolute value function, this must be y equals 2x plus 1, and this part of the line must be y equals negative 2x minus 1. So to find the point of intersection, so to find point A, we solve these two equations simultaneously. So we solve y equals 2x plus 1 with y equals x plus 2. We solve those two simultaneously. Now because they're both y equals, I can just go 2x plus 1 equals x plus 2. What I'm really just doing is subbing one equation into the other and just solving that. 2x minus x equals 2 minus 1. I get that x equals 1. So I can see that for point A up here, I can see that the x value is 1. All right? So I've got that there. Now, to find B, or the x-coordinate of B, so B is the intersection of this dotted line with the straight line. So this dotted line is y equals negative 2x minus 1, and the straight line is y equals x plus 2. So I solve y equals negative 2x minus 1, which is this one here, with y equals x plus 2. So I've got equation 1 and 2. Because they're both in the format y equals, I can just put them equal to each other. So I'm just going to go x plus 2 equals negative 2x minus 1. It doesn't matter which way you do it. Bringing this over, I've got x plus 2x equals negative 1, take away 2. So I've got 3x equals negative 3, and dividing through by 3, I get that x equals negative 1. Now, I can see that my solution for b, or b, has an x value of negative 1. Okay, so therefore the solution to absolute value of 2x plus 1 equals x plus 2 is going to be, from the graph, x is 1 and negative 1. However, when you solve it using algebra, you must write the two forms of the equation, because you do have two different lines, and you have to see when this line with the positive gradient cuts the line y equals x plus 2, and this line with the negative gradient, when that cuts the line x plus 2 as well. Okay. All right, and if you want to find y values, you would just substitute into the original equation. Okay, but because we're asked to solve this, we're only asked to solve for x, so I don't need the particular y values.